Is Spacelift a viable alternative to Terraform Cloud? Today we're going to break down what these tools do and take a closer look at Spacelift as a platform for your Terraform deployments. So we have these infrastructure as code tools such as Terraform to maintain the state of our infrastructure. Why do we need this extra level of tooling sitting above that? To answer that, we need to look at some of the challenges that we start to see as our teams grow and the complexity and size of our infrastructure increases. Let's look at some of the challenges that we face in a Terraform world. The first being state management. So Terraform is a stateful application and that state needs to be stored somewhere. Sure, you can make things a bit easier by using remote storage on something like AWS S3, but it's still an extra component that we need to manage. And as our teams start to grow, we start to see issues around managing this state when multiple team members are working on the same project at the same time. This can lead to problems with state locking and possibly even state corruption if not done right. So managing Terraform state is not something which is easily done just using the basic tooling available. The second reason why we might look at another level of tooling is remote execution. So if you're an individual just starting out with infrastructure as code tools such as Terraform, simply running Terraform from the command line in your Git clone is a viable way to deploy your infrastructure. But when you start working amongst a team, this becomes really burdensome. We ideally want to take a more GitOps approach and drive this workflow using GitHub and pull requests. And GitHub is a fantastic tool for collaboration and for code review, but how do we actually drive the deployment in our workflow? How do we actually deploy our changes to our environment? Lastly, there's various policy decisions that we'll end up making about what we can and can't deploy in our infrastructure. We may have environments where we want to enforce certain policies around security, resource management, or best practices. We may require a different approval chain for certain changes or certain tasks. We may need certain guardrails around who can make certain changes or decisions within our workflow. Relying on just manual review is not enough. We need a way to programmatically declare these policies. So policy as code. So we can write them once and then continually enforce them. So these are things that infrastructure as code platforms try and bring to the table. You may already be familiar with Terraform Cloud, which tries to address these requirements. Today we're going to have a look at an alternative tool called Spacelift. And we'll look at how we can use Spacelift to create a GitOps workflow around your Terraform deployments. One big differentiator with Spacelift, as opposed to things like Terraform Cloud, is that Spacelift is an infrastructure as code platform that tries to be agnostic about the underlying tooling. We can use Spacelift not only with Terraform, but also with Pulumi, with CloudFormation, with Kubernetes, and we even have Ansible integration. So in this video, we're going to focus very much just on the Terraform capabilities, but it's good to know that if and when your underlying tooling changes that manages your infrastructure, that Spacelift will continue to be able to provide that overall workflow management for you. So what we're going to do now is sign up to Spacelift, connect Spacelift to our GitHub repository, import a Terraform project as a Spacelift stack, and then see how the whole thing fits together into a GitOps workflow. So let's dive in. So we're going to start with a very basic Terraform repo that will just deploy an instance and a few resources out to AWS. So let's just take a quick look. I've got here my repository. I have a terraform.tf file here, which brings in the AWS provider. Here we can see my instance.tf where I'm just spinning up an EC2 instance in AWS. And I'm also going to do a little bit of DNS management here, setting up a host name for the instance and mapping that to my domain name. And then finally here in security.tf, I'm just adding a security group resource to allow SSH into my instance. So very basic. We're not going to go too heavy on the Terraform side because what we really want to see is how we manage this with Spacelift. So now what we're going to look at is, instead of running Terraform plan and Terraform apply from the command line here and driving this locally, we're going to import this into Spacelift and let Spacelift drive the workflow. So what I've done is pushed all that Terraform code up to GitHub. It lives in a repository called Terraform demo. And this is the repository that I'm going to connect up to Spacelift. So now we're going to head over to the spacelift.io website, and if we click over here on Get Started, we can see it offers a variety of different ways that you can sign up, either using GitHub or GitLab or your Google or Microsoft account. So choose whichever one you prefer and get signed up. Once you've signed up and logged in, you should see something similar to this. So this is the dashboard view within Spacelift, and we can see we start off here in this area called Stacks. So stacks are the fundamental building blocks of Spacelift. This is where everything starts. Within a stack, we have the repository that contains the Terraform code that you want to deploy. We have variables that feed into that, and we have the state management located all within this stack. So before we can connect our Terraform repository to our stack within Spacelift, we need to give Spacelift access to our VCS or to our GitHub repositories. If you signed up using your GitHub account, then this has probably been done for you, but if not, you need to head over down to Settings and Source Code. So here we can see that Spacelift provides integration into a host of different VCS backends, GitLab, Bitbucket. For this demo, we're going to be using GitHub. So I'm going to click Setup here, and then I'm going to use the wizard, which will automatically install the Spacelift application onto my GitHub account. So use the wizard. I'm using github.com. This will also work if you're running self-hosted GitHub. I'm using my personal account. And here GitHub lets me confirm that I want to connect Spacelift to my GitHub account. So as it says here, before I can use it, I need to enable the application on my GitHub account. So I'm just going to click the link it gives me here, which will take me back to GitHub. And now I can just install the app. I'm going to give it access to all my repositories, but you can select individual ones if you need to. And now I can see that is now installed. Now I'm going to go back into Spacelift. Now if I go to stacks, I can add a new stack. We're going to call this one TF Demo. And I can give it optional labels, which is useful if you're dealing with a lot of stacks to better differentiate between them, or a description. So I'm just going to call this Terraform Demo. Hit continue. Now we can see the next step is to integrate the VCS, and because we've connected our GitHub account, I can see in this drop down here all of my repositories. And I'm just going to search for my Terraform Demo repository, which I can find here. Branch main. The project root I'm going to leave blank because it defaults to the root of the repository, but if you are running multiple projects within some kind of monolithic repo, then you can specify the root here. Here I configure the backend to my stack, so by default it's going to use Terraform, but as we mentioned earlier, Spacelift supports Pulumi, CloudFormation, Kubernetes as well, so we can use Spacelift to drive any one of those workflows, but let's leave this as Terraform. We can specify a specific version of Terraform that we want this to run under. This is really handy if we're using new features or deprecated features within our Terraform code and we need that pinned to a particular version of Terraform. So here we have the option for Spacelift to manage the state for us. So Spacelift can completely manage the state for you, or if you want to continue using your own state backend in AWS 3 or elsewhere, then you can continue to do that as well. But for now, I'm going to say manage state, and then we can continue. Here we have some more advanced options that we can tie to the stack, which I'm not going to go into in too much detail now, so I'm just going to leave those as default and save my stack. So now I can see I'm within my TF demo stack. I can see the Terraform version being used here. I can see the repository that the Terraform code is stored in, which is on my GitHub account, which branch it's on, and the latest commit that's in that. So before we can trigger any runs in this stack, we're going to need to give Spacelift access to our AWS account with the credentials it needs to be able to deploy the resources. One of the possible ways of doing this is using environment variables. So if we go into the TF demo stack here, we can see at the top we have a tab called environment. And here I can specify environment variables that will be applied to this stack. And I can store those as secrets as well. And because the AWS provider for Terraform allows you to specify access credentials as environment variables, the access key and secret ID key, we could just generate a secret access key and inject it into the stack as an environment variable. But Spacelift supports a more native integration with AWS and other cloud providers in its cloud integration features. This will allow Spacelift to assume a role within AWS and get issued temporary credentials to use just for that session or for a time-limited period. So in order to use Spacelift's cloud integration functions against AWS, we're first going to need to create a role on our AWS account. So in the Identity and Access Management section within AWS, I'm just going to create role. I'm going to give the role a custom trust policy. For now, we're going to use this example trust policy that you can pull this straight from the Spacelift documentation. This is fairly open, so the external ID here, we need to just change this with our Spacelift account name. So this is fairly open, just saying that everything under the Craig Dunn account within Spacelift can assume this role. In reality, we can fine-tune this down to individual stacks and instances, but this is good to get us started. So we'll come down here and click Next. Now we probably want to attach some policies to give this role some permissions to do things. We know we've got EC2 instances that are run from here, so I'm going to just add the EC2 full access policy. And I'm also managing things in Route 53, so we're going to give it access to Route 53 as well. And then click Next. Give it a role name. we can just quickly review the trust policy here and the access policies that we've attached to it. So for Route 53 and EC2, and then create that role. Now we've got that role created, we just want to go into here and just copy the ARN to the clipboard because we're going to need that later on. So now let's flip back to Spacelift, and then down here on the left hand side we're going to navigate down to Cloud Integrations, and we can see we've got the option of integrating into AWS, Azure or Google Compute. We're going to use AWS. So I'm going to add first integration, give this a name, and then the role will be the ARN that we copied from AWS just now, and then we can create that integration. So now we've got the integration set up, we can go back into our TF demo stack, and if we come over under settings, we can see here integrations, and I'm going to select what type of integration I want to set up, which is an AWS integration, and then I can attach the integration that I've previously done, demo AWS. I want to give that read and write, and then just attach it. So now we've successfully hooked up Spacelift to our GitHub repository for access to all of our Terraform code, and we've given it the integration to our cloud provider, to AWS, to actually go off and manage those resources. So now I've got my Terraform code tied into a stack within Spacelift. There's various ways I can trigger a Terraform run now. So I could just click the trigger button here. So here we see behind the scenes that Spacelift is spinning up a Docker container where it's going to configure our Terraform environment, and then it's going to start planning our run. So we're just going to skip forward a little bit here. Now we can see we've initialized our Terraform environment and we've just done a Terraform plan, and we've got 3 resources to add. So now we can see that this run has moved into an unconfirmed state. And if we look down here, we can see all of the changes that will happen if we trigger this run from the Terraform plan. And if we're happy for those changes to go ahead, we just click confirm here, and then we move on to the next stage after planning, which is the actual applying of our Terraform code. So now we can see Spacelift has invoked Terraform and it's actually creating my resources up in AWS. So we'll skip ahead to the end. So here we can see we've got a Terraform apply complete message. We've got 3 resources added and nothing changed or destroyed. And the status of our run is finished. And we go back to our stacks overview here. We can see that the status of this stack now is green and the last run finished successfully. So that's how we trigger a run manually in the Spacelift platform. Let's have a look now at a more GitOps workflow of using GitHub to interact with Spacelift. So now I'm going to make a pull request into our Terraform repository to make a change to the Terraform code. So I'm just going to switch to a new branch. And we're going to add a new file here called network.tf, and I'm just going to create a AWS VPC. Let's put it on, let's say the 192.168.0.0 network. Save that and commit. And push. So let's raise our pull request. So now what we see on our pull request is that we have Spacelift checking in here to run a job against our pull request. And if we head back over to here, under our stacks view, under TF demo, we can go into PRs here and have a look at the pull requests that are pending. And if I click into that, we can see that it is doing a Terraform plan on my proposed changes, and it's finished and showing as a successful plan that wants to add 1 resource, my VPC, into AWS. And if I go back to my pull request, I can see that's showing up now as green within here. So we get visibility from both sides, from the GitHub end and from Spacelift itself. So now we're happy with the results of this plan. We can go back here and merge the pull request in GitHub. Once that's merged into the main branch, if I go back here into Spacelift and go into my stack again, we can see that my merged pull request is now running a job on the TF demo stack. And if I click into that, and then very much like when we ran this as a manual trigger in Spacelift, this has finished all of the planning stages, everything's come back green, and it's switched to an unconfirmed state. So here I've got a couple of options. I can type in here and share your thoughts. I can leave some comments on here. If I'm not happy with this going out, I can discard this run. Or if everything's good and it looks good to me, click confirm, and then we should see this apply our Terraform code. And here we see Terraform's finished applying. I've got my extra resource added here, my VPC, everything that looks good, and this is changed to a finished state. So now we've seen how Spacelift can give you the tooling to implement a GitOps workflow across your Terraform deployments. One of the other really powerful features with Spacelift is policies. Policies within Spacelift are a really powerful feature. We can declare policies to manage users' login rights, to decide who has administrative access to what features within your workflow. We can create policies to notify us of certain conditions so we can get more visibility of what's going on in our workflow. We can also use policies to inspect our Terraform plans and put some guardrails around what can and can't be deployed. So now with Spacelift in the mix, we now have our infrastructure as code defined within our Terraform, and we've also got all the policies around not only our infrastructure, but our workflow in general, also defined as code. And that's a really, really powerful feature. So Spacelift uses the policy engine Open Policy Agent under the hood, and we normally write policies in the Rego language, and that gives us an incredible amount of flexibility into what we can do with policies. So let's jump back real quick to our project, and I'm going to implement a policy against the workflow that we currently have on our demo stack. So if we go back to the main dashboard, on the left down here we have the policies section. So we can see there are a couple of policies that have been pre-written for us, and one of these is available on the free tier for enforcing password strength. So I'm going to add a new policy for my plan. I'm going to choose a fairly basic example. So if I go back to my Terraform code here, we can see that as part of my Terraform setup, I deploy an AWS security group resource out to AWS, and this provides me with inbound SSH access to my instance. So down here, I'm specifying the from and to port to be 22 for SSH. So now we're going to implement a pretty trivial policy. What we're going to say is that whenever we have an AWS security group within our Terraform deployment, that the ingress ports, both to and from, must be 22 and not any other port. In the real world, we'd probably have something a little bit more nuanced, but this will do for this demo. So let's go back over to Spacelift. So within policies here, I'm going to add a new policy. I'm going to give it a name. And now I'm going to select which type of policy I want to create. So here we can see we've got policies associated with pushes, with logins to the platform, with triggers. We want a plan policy because we want this policy to apply whenever we want to run our Terraform plan. And if we look further down here, we've got quite a bit of boilerplated stuff commented out, but this is quite helpful if you're just getting started. To give you some examples, I'm going to delete all of this. And so we're going to write our policy in the Rego language. I'm not going to dive deep into the Rego language itself. That's a topic for a dedicated video. But let me just explain roughly how this works at a very high level. So we start off with this declaration here that basically says that we want to deny. We'll give it some meaningful message to come back with. And then anything within these braces is the conditions that we're going to deny this policy. So anything within here will evaluate to true or false. And if this evaluates to true, then we want to deny the policy. And if it evaluates to false, then we allow the policy. So in this first block here, all I'm doing is filtering down all of the resources in the plan to just those that have the type of AWS security group, because they're the only ones that I care about for this policy. Now here I'm going to assign a new variable called resource, and that's going to iterate over all of the resources within here that we sourced from this section up here. So resource will iterate over all of our AWS security group resources within the Terraform plan. Below that, we can put our assertion, which will evaluate to true or false and give us the result of the policy. So here we want to say that if any of these conditions are met, if any of these conditions return true, then we fail this policy. So here we're going to drill down into the resource tree. We're going to look for changes, and specifically we're interested in changes to the ingress section of an AWS security group resource. That can be a list, so we're going to iterate over all ingress blocks within each AWS security group, and we're going to check to see if the from port is anything other than 22. And then we do the same down here for the to port. So what we're saying is, if any of these conditions match, if ingress from port is not 22, or if ingress to port is not 22, then we will fail with this message here. In the real world, we probably wouldn't have such a blanket policy, but for now this will do. So we're going to create this policy. And we can see now it's in our list. It's a plan policy called check port number. So now let's go back to stacks, go back into my TF demo stack. And if I click on settings here, I can then go into policies on this tab here. I currently don't have any policies attached to this stack, so what I can now do is drop down here and I can see my check port number policies available, and I can attach that to this stack. So now we have the policy in place. Let's make a change to our Terraform code and see how the workflow changes. So I'm going to do this as a pull request, so I'm going to create a new branch. So here we can see our AWS security group resource within our Terraform code. So here we can see our ingress block, which is currently mapping port 22 to port 22. I'm going to change this to map from port 22 to port 8080. Now we're going to save that change and push this up to GitHub and create a pull request. Create pull request. Done. And now I can see that Spacelift has checked in to run a job on this pull request, and if I click on details here, I can see the job running, and I can link straight to that job from GitHub here back to Spacelift. So the check port number policy has flagged the fact that I have an invalid port number in my proposed change and has denied it. So if I go back and make the change here to make this compliant with our policy, so change to port back to port 22 and push that to my pull request. If I look back here on Spacelift now, now we're back in the planning stage. Let's see what happens. So here we can see there's no changes that Terraform wants to make because we've just changed the port back to 22. But the interesting thing here is now we can see that this policy was still applied, but this time it's passed and it's allowed that to go through. So this has now finished. And if I look back at my pull request, I can see we now have a green tick because the tests have passed and we're good to merge. So we've seen how to create a stack. We've seen how to import our Terraform code into that stack, run our deployments, and now we've seen how we can use policies to put some guardrails around that. So overall, Spacelift is a very good alternative to Terraform Cloud, but it aims to build on top of Terraform Cloud. It aims to give you a true GitOps workflow with seamless integration into GitHub, and the flexibility that Spacelift provides with policies is really, really powerful. So before we close out, let's just touch on pricing a little bit. So everything I've done in this video has been within the Spacelift free tier, where you don't have to sign up for any paid services. Within the free tier, we get support for all of the tools that we just mentioned, like Kubernetes, CloudFormation, Pulumi, Ansible. We can bring our own custom Docker images to run on our workflows. We get access to the OPA policy framework, which allows us to write unlimited amounts of policies. So the free tier really does provide you with all the tools you need for a pretty comprehensive, powerful workflow. So if you want to take it up a notch, we can look at the Spacelift paid tier. So Spacelift operates a pretty flat paid tier system. So for $250 per month, you get 5 users, and then you can add extra users for $10 a month on top of that. The paid tier within Spacelift obviously gives you everything that was included in the free tier. You get some more concurrency, and you get a bunch of extra features that are highly geared towards really power users. So now let's just have a quick side-by-side glance at Spacelift and Terraform Cloud. We've already discussed that Spacelift is positioning itself as a platform that's tooling agnostic, whereas Terraform Cloud is quite obviously just developed for Terraform, for HashiCorp's own offering. The execution model within Spacelift is all executed within Docker containers, and you can import your own custom images into that. That means it's easy to support extensions and wrappers such as TerraGrunt, and with Terraform Cloud these features are pretty limited. Both Spacelift and Terraform Cloud both support the idea of policies, but with Terraform Cloud you're quite limited in the number of policies that you can create. With Spacelift you can configure as many as you want, and it's all handled by the open source Open Policy Agent framework. Both tools also offer the feature to manage your Terraform state, but with Terraform you're locked into using that. With Spacelift, Spacelift can manage your state, or you can continue to use whichever state management solution that works for you, whether that's on AWS S3 or some other external backend. Spacelift has really good VCS integration, not just with GitHub, but with Bitbucket and GitLab as well. And integrations with other tools is a really strong feature of Spacelift. Spacelift effectively gives you the ability to integrate with an unlimited number of tools, whereas with Terraform Cloud, this is limited to just supported tools. So in this video, we've looked at some of the key points of Spacelift and looked at that side by side a little with Terraform Cloud. If you've got any questions, then please leave them below. Check out some of the other videos on the channel if you want a deep dive into some of the other powerful features of Spacelift, and subscribe for more videos like this. I'm Craig Dunn. Until the next time.